Ladies and gentlemen, carbon monoxide is known as the unnoticed poisons and silent killer of 21st century. The effect of inhaling carbon monoxide can cause brain injury and even can cause death. If you can recall, there was a case of carbon monoxide poisoning to a group of 3 young women who died when they fell asleep in their car at the parking lot of a petrol station in Perak, September last year. So exposure to carbon monoxide can cause death. It can also relate to premature birth and autism disorder among children. Other issues are like headaches, nausea, dizziness, and disorientation. So what is the level of carbon monoxide pollution in Malaysia? Are we all living in the safe zone? Let me now begin my presentation. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Dr. Muzalwana Abdul Talib, a senior lecturer in Department of Applied Statistics at the Faculty of Economics and Administration, University Malaya. And I am an applied statistician, and my area of specialization is statistical quality control. I'm also teaching a course under the Master and Applied Statistics program, which I designed myself, called Statistical Quality Management. So statistical quality control was originally established in the field of engineering, but later on this technique is also applied in other studies like health studies, social science studies, for example, service sector. And in this presentation, I will share with you the application of statistical techniques in the field of environmental studies. And the title of my presentation is Monitoring Ambient Carbon Monoxide in Malaysian Urban and Industrial Air with Cumulative Sum Control Chart. And this is the flow of my presentation. I will firstly dwell into the background of CO emission effect on human health and climate change, which is an important issue to the environment. I will further proceed to the efforts to curb air pollution problem in Malaysia, followed by how to apply cumulative sum control chart to examine the trend of CO emission over 5-year period. Lastly, I will proceed with the analysis, results and finding before I wrap up this presentation with the concluding remark. So carbon monoxide is the most widely distributed pollutants, affecting more than 50% of global air pollution. Abundant presence of CO emission is a great concern due to its effect to the concentration of greenhouse gases, which have a direct effect to the climate change. Goal 13 of the Sustainable Development Goal, SDG 13, has clearly urged to combat climate change by improving air quality. This is not only to protect human health, but also to preserve the ecosystem, food security, and its wider implication on socio-economic development. The highest global emission of CO was initially detected from the Northern Hemisphere, which is from Europe, North America, and Asia. However, for the past 2 decades, also reported was the declining trend of CO emission in South Korea, China, and Japan. But again, in Malaysia, the trend is reversed. High CO concentration in Malaysia was observed in 2008 until 2016. The other major contributor, industrialization and urbanization, which have given rise to loads of anthropogenic pollutants in Malaysia. In 2017 alone, the emission of pollutants to the atmosphere in Malaysia was largely sourced from anthropogenic causes like vehicle emission, that is 70.4%, power plant 24.4%, 24.5%, industrialization 2.9%, and fire burning 2.1%. All this data came from the Department of Statistics Malaysia in 2018. So to curb the air pollution problem, under the Malaysian Ambient Air Quality Guidelines, or MAAQ QG, which was developed by Department of Environment, has recommended the CO breakpoints, which is considered as moderate to human health, and this is around 4.5 to 9.4 ppm for 8-hour averages time. These standards are derived based on empirical studies on evaluating air pollutants' impact on the human health. Malaysia also has enacted the first Environmental Quality Act in 1974, after which it went through a series of revisions to deal with air pollution problems in Malaysia. At international level, Malaysia has worked with neighboring countries to address air pollution issues, like for example, the Asian Haze Agreement, which considers the precarious effect of transboundary haze pollution. Among others, in this agreement, each party will not only take appropriate measures to monitor haze pollution arising from their own land or forest fire, but also the environmental condition conducive to such land and forest fires. In SDG 2020 report, these are considered as negative transboundary impacts from a country to another. This is because it will undermine the other countries' capacity to achieve their SDG goals. At national level, Malaysia has its Industrial Air Pollution Control System, IPCS, which has been made mandatory for all industries in Malaysia to be equipped with an air pollution control system. I will now move on to the problem statement and research objective of this study. The effect of urbanization has led to growing number of vehicles. Coupled with industrialization, the level of CO concentration will continue to increase. Even worse is the fact that CO air pollutant has a long life expectancy in the atmosphere. That is, on average, up to the period of 3 months. This makes it almost similar to air density, which means to say that it can easily spread through narrow spaces. The World Health Organization guidelines on CO level and their respective duration of exposure time is only for a short period of time. For example, 8.7 ppm for 8 hours. There is no additional guideline on longer time spent on CO exposures, like for example, duration of months or even years. And there are only a handful of studies on prolonged exposure to low level of CO. Some of the study has actually related to the effects of CO on brain, and a much earlier study has suggested an association between low level of CO and hospital admissions. So in this study, I would like to examine the long-term small scale of CO concentration in selected industrial and urban areas of Peninsular Malaysia by adopting the cumulative sum control charting techniques. But before that, allow me to go through briefly on the statistical quality monitoring approach. The main purpose of quality monitoring to alert if there's any deviation observed in quality characteristic from its main target. In statistical quality approach, deviation from main target signals the presence of variation, which can lead to unstable condition and ultimately lead to quality deterioration. To study this means and variation, control chart is a popular statistical tool that has been used to indicate if there is any changes in the quality variable that could lead to the situation of out of control. So control chart was the technique which has been used. This technique allows one not only to instantaneously uncover the existence of problematic condition which could have affect the quality, but also it enables one to detect when exactly it has occurred. This is because control chart takes into consideration the time factor. And the evaluation of SPC methods, particularly control charting technique, also allows the application of measuring environmental performance and its data analysis. So in this study, we will employ a time-weighted type of control chart, namely Cumulative Sum Control Chart, to study long-term trend of CO emission. For the data, for the sample data, we will utilize the secondary data of carbon monoxide emission from the Malaysian Open Access Data, which is MMPU, and from the Department of Environment under the Ministry of Water, Land and Natural Resources. Data was also gathered. The data gathered was actually for industrial and urban areas in Ipoh Perak, Pasir Gudang, and Muar in Johor. And we gathered data from years 2007 until 2016. So we are now into the Qsum control chart. Yeah. So Qsum control chart is a memory. Again, it's a memory type of control chart which combine information from current and past observation. This technique is very effective in detecting if there are any small magnitudes of shifts from the target value, which is usually the mean values. So a two-phase Qsum control charting scheme is applied for this purpose, and specifically the one-sided upper Qsum is chosen because it is deemed to be appropriate technique to the nature due to its suitability to the nature of air quality control, where there are no minimum limits for CO pollutant emission in the environmental context. Under this technique, phase one is the phase of estimating the parameter, which are the mean value and standard deviation. For this purpose, the individual and moving range control chart has been applied for the data set from 2007 to 2011. And under phase two, Qsum has been applied by using the parameter which has been estimated from phase one. And this will show if there are deviation in the observation from the target value. And for phase two, we use the data from 2012 to 2016. So these are the two different sets of data. The first set of data is to estimate the parameter. Then the estimated parameter is used onto the second phase data on which we apply Qsum control chart. Okay. So we come now to the results and findings. From the descriptive table here, the CO concentration in urban area are relatively lower. Yeah. In the urban area are relatively lower than the respective industrial area. However, CO emission in the North Region station are less varied, yeah, showed by the value of standard deviation, yeah. But bear in mind that all these values are still lower than the recommended concentration value given by the MAAQG, yeah, which is 9 ppm for 8-hour averaging. Yeah? But again, those values given by MAAQG are for short-term exposure. Yeah. Okay, the results from individual and moving range chart. For phase one, well, this is phase one, so the data set belong to 2007 to 2011. Yeah, so the average CO in North region varied from 2007, yeah, until towards the end of 2009. Yeah. Followed by huge variation until 2011. Yeah, a huge variation here. In the North Urban, large variation are detected. Okay. Towards the end of 2019, South Industrial area also has huge variation of CO emission. But for the South Urban, we can detect the cyclical patterns. Yeah. So for this phase one, after an iterative process of outlier deletion, where all points are within the control limits, we can estimate the parameter. Yeah, so this is called the state of statistical in control, again, where we can estimate the parameters to be applied onto the second phase of the control charting scheme. Okay, so we move on to the second phase where we apply Qsum control chart. So the Qsum control chart here generally shows that most of CO readings went off, yeah, the target values. So these are the values on which they should be to be in order for them to be say in control. Yeah, but however, from all these chart, it shows that all values are way above the limits which has been set based on the estimated parameter from phase 1. Okay, so what we can say that overall all processes has started to undergo mean shifts, and they were all out of control towards the end of the period of study. And if you look at this trend, there are a persistent and consistent increase. Yeah, we should also expect it's still increasing till now. Yeah? We do not know about that. Okay, right. So as a conclusion, we can say that, well, CO emission is actually the product of urbanization and industrialization. And this study has clearly shown that CO emission in Malaysia, especially in the urban industrial area, has increased significantly over the period of study. And that is around 15% of increase in the industrial area and more than 50 to 70% in the north and south urban area, respectively. This study also confirmed the prolonged and persistent mean shift of CO emission, which is way above the target value for both areas. Yeah? So while CO emission is decreasing across the globe, the trend is reversed in Malaysia urban and industrial area. Urbanization and industrialization is likely to continue. Yeah, there's no stop towards that. With the outbreak of COVID-19 pandemic, there is a projection drop of greenhouse gases in 2020 has been which has been made known, yeah, in the news, yeah, which is due to travel bans and economic slowdowns. But however, this emission will increase back due to higher levels, when economic recovery takes place. Yeah? Moreover, the perilous transboundary haze tends to hit Malaysia every year. Yeah? So the effect of long-term low CO exposure to human health, for example, birth outcomes, all still remain unknown. Okay, we do not know. We also do not know what is the safe range for longer time of CO exposure. So a long-term sustained increase of CO concentration level is an important issue and should not be neglected. Okay, CO emission is indirectly affecting the climate change. Hence, it will impact human health, ecosystem, and food security. These issues need to be addressed for a safer and more sustainable future of the citizen. Okay, so before I end up, I would like to express my appreciation to the third LIMC 2021 Secretariat for giving us the opportunity to join this conference virtually and being able to present through this online video presentation. Now we are all get used to the new norms, but we still need to stay vigilant and stay safe. Thank you and Assalamualaikum.